It's crazy. I wasn't expecting to be giving this talk.
Is Ntari live?
Last we checked, yes. New Ntari, our fearless head of network operations here, is currently recovering. I am the other guy who runs network operations here, so I'm going to try and give you the story about running Notacon's network. I will probably be very, very different in content, and I desperately encourage you to ask me questions because I have no idea quite where I'm going with this. But I can tell you one thing. It definitely is a trap. Anytime somebody asks you to run a network for a conference, say no. If they ask twice, say no and run away. The only reasonable thing to do when somebody asks you to show up and say, please run this network for us for a weekend on environments you don't understand, in places you don't have everything laid out, is to say no. Thankfully, we have a number of exceedingly unreasonable people who put the network together. I'm going to go somewhat out of order and slightly off kilter. Expect me to diverge at any point. First, history of network at Notacon. I have been here every Notacon since Notacon 1. We've had a network every year except Notacon 1. Notacon 1, we actually didn't have any network at all. We chose not to have a network at Notacon 1, and then we learned that that was a really bad idea. The number of stories that were boiled down to, oh God, where's a Starbucks? I need to download my slides. When that exceeded 3, we understood, okay, we really do have to bring a network to the conference. Years 2 through 5? Yeah, that sounds about right. 2 through 5. We were at a different hotel, and we realized we needed to bring in more internet than the hotel had. They had like a T1 line. T1 lines, as everybody here knows, absolutely 100% crush any experience of latency that you want in a network. Put 100 of us in a room, a T1 line does not survive. Put 200 or 300 of us in a room, I don't care how many T1 lines you have, it's not going to be good. What we ended up doing for those years was we had roof access. We ran Ethernet cable all the way up to the roof and built a wireless bridge to a wireless ISP in Cleveland that worked with us. And we got 20 megabit in over a wireless connection from the roof, down the stairwell, down the Ethernet cable, into the back of whatever gear we could acquire in a pile, and generated network out of it. Now, this was 2003, 2004 timeframe. We did some interesting things at that time as well. We had wired network. Wireless hadn't taken off yet. So in addition to how do we drag infrastructure around this hotel, we also ended up trying to figure out how do we get switches out to all the tables? How do we get switches for people to plug into? Where do we come up with Ethernet cords? These things are shockingly bulky. Still are. We'll get to modern network here in a bit, but networking at that point was, okay, we have internet. Wait, speakers want connections too. Okay, we have Ethernet cables dragged to the speakers. What do we do with it then? Wait, everybody's fighting for the same megabits. This is a problem because speakers have to actually have access during their talk. They need priority. A lot of interesting questions started showing up along the line, and we were making this up as we went. Let's see. So we slowly started evolving how we built networks for Notacon. At about Notacon 6 or 7, the leadership behind network changed, and I started getting involved as well. Prior to that, I just showed up at Notacon and didn't build networks. I do this for a day job, and my theory was I shouldn't do my day job at my weekend event. Clearly a mistake. Doing it at the weekend event is so much easier than my day job. It almost doesn't feel like work. We ended up in the corner where we realized that the network actually had to support more than just user interaction, and the way people interlinked changed. Used to be 10 megabit hubs on the table were just fine because everybody had an Ethernet cable, and this wireless thing was clearly some wacky thing that it would go away. Now, well, I suspect that I know I'm carrying 4 or 5 devices that have wireless Ethernet cards in them. I'm sure the average is about 2 around here. User interconnect changed to wireless. Okay, we had to adapt to that. At the same time, we had to adapt to, we need network for more than just getting to the internet. We need stuff for, okay, user access on wireless, sometimes wired. We also need AV access. AV actually is a very network-intensive operation at this point. We also needed speaker access. Speakers needed the ability to get priority access to the internet during their talks. And then things like Pixel Jam started showing up, and it's sort of like, okay, we want to live stream this to the internet. This requires shaping the network because effectively there's no way we can find enough bandwidth. It does not exist. We could get 10 gig pipe to the internet, it wouldn't matter, we would fill it somehow. This has evolved the tool set we use for doing this. The trick we've come up with today, and I'm jumping way down the path here, and again, please feel free to ask questions at any time. We don't try to build our own interlinks to the internet for this weekend anymore. We go with whatever the hotel has. That's not always great, but it's definitely a mechanism. We do that because actually trying to get a connection for a weekend is pretty much impossible and extremely costly. Reality of networking. All of the cost is in putting the connection up the first time. The bits are essentially free after you put the hardware in place to move them. So a weekend-long connection is all of the cost of a 10-year-long connection concentrated in a single weekend. The bits are free. Establishing all of the network engineering to put that up and then tear it down in a weekend is incredibly costly, not only to you, even if you can get your own free labor. Oh, awesome. Excellent. The HVAC system is calling us. You end up in the state where you end up paying all of the hardware cost for an entire weekend, all of the setup time, all of the teardown time, and don't get the 10 years of moving bits in between to recover costs on a monthly basis. This is true for essentially any connection. Wireless, fiber, DSL lines, all of the cost is in establishing the circuit and tearing it down, not in moving it once it's up and running. This means that if we wanted to actually get custom circuits installed for a weekend, we're probably looking at tens of thousands of dollars. We aren't going to do that. Our pockets aren't that deep. And most of the networking gear comes from donations, loans, and stuff we scraped out of our basements. That's a reality. We've moved to a mechanism where we operate a VPN tunnel from the CON network back to a host ISP, Amplex Internet. They're absolutely wonderful. Their CIO helps us run the network here. This VPN tunnel allows us to do packet shaping before the packets made it down through the incredibly narrow connection to us. The trick behind this is, if you're going to shape, most packet shapers operate on the premise of, I see packets, I then choose which ones that I forward and which ones I don't forward, or maybe I delay them. The packets have already transitioned the path down to the local end. This means they've already burnt the bandwidth on the narrow section of the network, and they're now locally, what do I do with them? Well, the only reasonable thing to do is deliver them, because if you actually drop them on the floor or delay them, the other end retransmits and makes your problem worse. So the mechanism we use is we drop and delay packets at the ISP side and choose which ones do or do not make it through the narrow pipe over there, so everything that makes it down to us, we forward on. So we actually rate limit the bandwidth back at the ISP, not actually locally. This makes it possible on limited bandwidth environments, and don't get me wrong, I understand it's like 4 or 5 megabits we have right now, that SSH sessions still have reasonable latency, and that BitTorrent doesn't destroy the entire network. Different story. that's stage one. Stage two was we had to shift up to using VLAN-aware networking hardware. We use VLANs across the network as we've built it in here to isolate and separate traffic from the various groups that need priority access to those that want it, to those that, yeah, okay, we'll give you what we can. VLAN separation is key to building any controlled environment of the network. This is more challenging than you might think because consumer-grade hardware doesn't really do VLANs. Not well, not with QoS, not with any number of other things. Rate limiting filters, that stuff doesn't exist in consumer-grade hardware. We are exceedingly lucky. Year after year, we find a company or a vendor who's willing to let us borrow hardware for a weekend. We've been using Juniper hardware for the last several years. Centricom has loaned it to us this year. Previous years, it's been Juniper Direct or whatever we've been trying from the basement. Enterprise-class hardware makes all the difference in the world in containing how bad the problem is. We can do filters on rate limiting. We can do priority. We can do VLAN tagging. And we can build the necessary infrastructure to manage the traffic. When I said consumer hardware doesn't do VLANs, that's mostly true. Turns out there is some consumer hardware that does. If you guys are familiar with the venerable WRT54G Linksys wireless routers, yes, that's what provides Notacon wireless here. Here's the entertaining thing. Internally, they are constructed on a VLAN-aware switch. If you load custom firmware onto them, you get a 16 VLAN switch that you can interact with and trunk data in and out of. This is how we provide access for speakers, this is how we provide access for AV, and this is how we provide wireless access. I have switches laying around here that have a trunked port. They're WRT54Gs. One of the VLANs contains the wireless, and it's just bridged straight onto wireless. You can't actually talk to the machine underneath. One of the VLANs is trunked out or tagged out to one of the ports, which allows AV access, and another one is tagged out to provide speaker access. If you plug into one of those ports, you actually get priority traffic in and out of the network. If you're on the wireless, you get whatever we have available to you. Careful management, filters, rate limiters, priority access. That's pretty much the secret sauce that makes a network operate in a bandwidth-constrained environment. Let's see. Physical infrastructure. We get dropped in a hotel, and we have about 12 hours to figure out how to get wires run everywhere to accomplish this across anything and everything we find. Show up with a lot of Cat5 and a lot of ends and people who can crimp the ends correctly. If you can't find people who can crimp the ends correctly, don't hand your crimping pliers out. You'll just have to fix it later. It does, in fact, matter what order the wires go in. On the other hand, anybody who's willing to drag wires for you, take their help. Point at the wire from point A to point B, drag it across the room, tape it down. Okay, I'll come put the ends on. The only way this works is that we have a dedicated group of people who are crazy enough to actually run a CON network. I'm one of them, I admit it. I probably can't get all the names, and I'm not going to try. I apologize to everybody. I'm not going to try and name them all. They probably wouldn't want me naming them anyway. When you show up, you have to be able to adapt rapidly to whatever environments that are here. This network is actually two entirely separate wiring plants separated by a chunk of fiber between two closets. So it's hard to find consumer hardware that actually has SX gigabit Ethernet connectors on it. This is why enterprise-grade hardware matters. You can actually get the ports you need to work on the existing wires. Otherwise, we'd be dragging wires across the roof. And dragging wires across the roof usually works for about 12 hours until the lightning strikes them. then it's not so much fun anymore. Services. So 5 years ago, we were dragging in probably 4 or 5 tower computers to every Notacon to run all of the necessary services that are inside of the network. We have caching name servers here. We actually have a squid proxy that speeds up an awful lot of the web browsing. What other pieces? Management software, lots of graphs, lots of pretty graphs. These are extremely useful to figure out what's going wrong. You need to see how many bits are flowing, where they're flowing, and why they're flowing. It's shocking how effective a simple graph is at pointing at the problem because, hey, let's graph this by bandwidth consumed per IP address, and one of them sticking all the way up and everybody else doesn't exist. I bet that's the problem. Let's go look at that one. Most problems show their face easily. The next step is people go, well, are you going to do something complicated with blocking them or cutting it off? Well, no, usually I just wander over to the device in question and unplug its network port. This is vastly more effective than any sort of careful filtering that I would write. I have tools to automatically write the filters, but as a communication mechanism that something has gone wrong, the plug being unplugged from the device with a note saying plug this back in at your own risk does a vastly better method of getting the point across. Sign it, just knock, and people will show up and say, what did I do? And then you can help them. You can help them set it up in a way that does not damage the entire network in the process. Communication, huge, huge thing. There is so much communication of people necessary to accomplish this. Hotel staff, event staff. We start months out in advance trying to get appropriate contacts because we only have 12 hours to set this thing up, and finding out the guy has left town for the weekend is challenging to work through. We like to make sure we know who we're going to call on the night when we're actually dragging the wires and going, where was that port you said you would have tagged out and labeled for us? Wait, I was supposed to do what? Okay, where would you expect it to be? We'll go hunting. If you do wiring, there are certain tool sets that show up that you want always with you. Tone probes, if you've never met one of these things, make your life vastly more solvable. One side of it plugs into the Ethernet jack and sits there and warbles. The other side is an induction probe, which you can hold up and listen to the wire just because it's causing so much RF that it causes an induction field and couples it out and you hear the audio. This is the only way we figure out how or where stuff is wired because there's one guarantee: the labels are wrong. The labels are a guideline at best. At other hotels, the only way we found our way through certain closets was, in fact, tone probes. And the entire closet was warbling at different tones for each wire we were hunting. And we had one guy in the closet with the tone probe describing the warble over the radio as high, low, high, and it goes, yeah, that's this jack. Pull it out, tag it, label it for the next guy, because there will be a next guy and he will appreciate what you did even if you never meet him. That next guy might also be you the next year, going, hey, we labeled this last year. Excellent. We know where this is now. Assuming nobody moved your tag, which, by the way, all labels are wrong. So the fact that it's labeled is a guideline of where to start looking for it again. You get 80%, you're doing pretty good. C, other pieces. There's a lot of hardware that it takes to move this stuff in. I figure I move in about 2 cubic yards of stuff. Cubic yards seems to be about the appropriate measure. It is 3 or 4 enormous duffel bags, one of which is filled with nothing but Cat 5 jumpers of various lengths, sizes, and most importantly, they were tested before they went in the bag, because there's nothing more frustrating than a Cat 5 jumper that doesn't work but otherwise appears to be correct, particularly after it's already taped down. because there's no way you're getting it back up because people are already in the room. So a lot of prep work is involved. Test all of your stuff. Test your wires. Make sure that your tone probe has batteries. These things are subtle, but they matter. And if you don't have them, you're in trouble. I don't have a lot of fiber stuff. We use whatever we have. Diagnosing broken fiber is not something you ever want to do without pro tools for doing so. So an awful lot of our fiber runs are boiled down to plug it in and hope it works. It lit. Okay, we're good. It didn't light. Flop the polarity and hope. We have never had a problem with that. I hope never to have a problem with that. I'm going to stop here for a moment. Does anyone have any questions that they would... Yes, sir.
The WRT 45P is still 100 megabits, right?
Yep. 100 megabit doesn't mean you can't put tagged frames through it. 100 megabit doesn't mean any number of things. Actually, don't do this. They'll handle jumbo frames.
I was about to ask
MTU issues. I should wander around those for a moment. But let's stick with the WRT 54Gs. Yes, they're 100 megabit, but the Wi-Fi radio is only 54, so it's really hard to consume all 100. This is, in fact, doing rate limiting through the wondrous power of the network simply doesn't go fast enough to break it. This works. It's not pretty, but it definitely works. The wireless side can only do 54 megabit one way or the other. This hands me 46 megabit for handling everything else going down that path. It is not policing. It is not shaping. It simply doesn't have enough bits off of one edge of it to go too fast. And the central switches actually do have policers making sure it doesn't pour more than it needs down at it. So upstream from the switch, there are no constraints. We're just holding on how much hardware can or cannot do. Downstream, we police how much traffic goes to each one of the VLANs. MTU. So we're doing a VPN back to our ISP. This means the MTU is smaller because you can't get packets more than 1,500 bytes wide across the general internet. We try, we hope, never happens. This means we crank down the MTU effectively. But we're on IPv4 for most everything. So it turns out that you can fragment packets. So there's a lot of fragments. Anybody who's running full MTU gets fragmented by the first thing in line, thrown across the VPN link, and all of the fragments continue flying out to the internet. Yay, fragment reassembly engines. This is how to exercise them. Occasionally we find out that this doesn't work for some subset of traffic. Not much we can do about that. This is why path MTU discovery continues to be a good thing. Not just on IPv6, as I mentioned yesterday, but also on IPv4. We do set up the necessary stuff to allow path MTU discovery to kick in and do its job, but we can't guarantee everybody's devices actually try. Any other questions? I see a lot of blank faces. Trying to actually stay on top of the Notacon network. So I mentioned VM servers, I've mentioned services. This year we actually got a lot easier. We stopped moving 6 or 7 tower computers. Virtualization is your friend. Use it. It's a lot lighter to move one laptop. Yes?
You guys swap out
stock. 100% stock firmware. Or excuse me, 100% stock antennas. The firmware looks nothing like stock anymore. And I have in fact I have a pile of workarounds for dealing with the WRT54G OpenWRT config language, which simply is not set up to do the stuff we're doing with these things. They don't understand the concept of, yes, I want to bridge. No, I don't want an IP address there. Yes, I want an IP address here as a separate management network that is not attached to anything except the trunked port, which has a whole bunch of tagged VLANs on it. all of that config is not designed into OpenWRT. They weren't expecting somebody to do stupid things we're doing with them. They make great home routers. They do great at that. But if you're trying to build a managed network out of them, it's pretty much a disaster. That said, if you hit it with enough sticks, you can get it to actually function. Anything else? Because otherwise I'm going to end this early and send you all on your way because I'm getting... Yes, sir?
Those fun OpenWRT extension dates, are those available? Share those?
If you would like to see them, you're more than welcome to them. What was the phrase? We're not closed source because it's particularly interesting. Yes, I'm quoting you. We're closed because it's embarrassing. But if you would like to see how they're configured, wander up to the NOC. We're up in Rockefeller. I'll gladly show you the configs, and if you'd like me to email them to you, you're more than welcome to them. They're not that interesting without the rest of the context. If you don't know how VLANs work, though, they're a great platform for understanding tagged VLANs and how those interact and doing horrible things with them. If you wish to break VLANs on cheap hardware and learn how they work, I highly recommend that class hardware. Because it's a lot cheaper than, the several $1,000 enterprise switch. And you need two of them before you can actually get anything interesting to happen. Trying to figure out how VLANs work on a single switch on its own, you aren't going to make very much progress. Yes, sir? Right, you have to be very specific about which... Okay, let me repeat the question, make sure it made it through. I say WRT54Gs. You have to get the specific right revisions. Those revisions are listed very carefully on the OpenWRT website. They have a variant now which is called the GL, which actually is not crippled. Modern ones, the key issue with most hardware design is how many parts can we get rid of to reduce the cost of the hardware. As you get rid of more and more parts, it becomes less and less capable of a device. Rev 4 and down, I think, is where it's at, is actually pretty decent hardware for doing... Yeah, it's... and I'm going to quote, 16 megs RAM, 8 meg flash. You can get a lot of work done with those. But as they evolved over the time, they continued to remove memory and flash and CPU and configurability, and it got much harder to do anything with. Go look up the hardware that you're specifically buying and the exact revision and understand what you're getting out of the deal. I think they have reasonable platforms that are now called the GL series that I think they continue to sell. They're more expensive, but that's because you actually have a platform to work with. And I should point out, these are the ones I happened to buy 5 years ago. I'm still using them. There's nothing broken with them. They do a fine job. There are probably better platforms today to work on than that. I haven't done the research because I haven't needed to. Sorry. Any other questions? Okay, so I'm going to repeat the question because I'm pretty sure it wasn't there. Yesterday morning, as we are desperately putting the network together, there was IPv4 support only, and somewhere over the course of the day, we added IPv6 support. The question was then, how does that interact with the WRT54G access points we're running? The answer is the WRT54G access points that we're running are in Ethernet bridging mode. They don't understand anything about the packets they're moving in IP land. They pick up an Ethernet frame and throw it onto the wired interface intact and as intact as it can be. They literally have no idea if there's IPv6 there or not. For all it knows, it's speaking Apple talk. It doesn't care. It's an Ethernet frame. This jumps back to one of the core elements of building large networks is you have to understand the difference between moving Ethernet frames around and IP frames. Turns out there's a lot of stuff you can do without actually thinking about the IP frame of the packet at all. And in this case, that's exactly what we're doing. The Notacon SSID has no IP knowledge at the access point. It's just Ethernet frames. All IP interaction on that happens back at the enterprise hardware. So, the answer, the access points have nothing to do with it at all. IPv6 was enabled at our on-site VPN terminator router firewall. At that point, we enabled the route advertisements there, and then you saw IPv6 light. Yes, sir?
How many wireless access points are there?
3. Turns out that's more than enough. As long as you aren't asking the devices to also act as DHCP servers, IP routers, IP masquerading engines, and everything else, and all they're doing is bridging Ethernet frames, turns out that you don't need a lot more than that to accomplish it. Also, they're all on 2.4 gigahertz. This is a rather small space. You can lay down more access points, but all you do is add to the amount of interference you're experiencing. We have considered doing 5 gigahertz, and we may do that eventually, but 5 gigahertz doesn't make it through walls. Which means that it would be great for everybody who had a direct line of sight to the access point, and not great for everybody else, because they'd all fall back to 2.4. Also, how many of your tablets, cell phones, or laptops actually have 5 gigahertz chips in them? Excuse me? Cool. Did not know that. All right. Say again? Make sure I heard you. Is 5 gigahertz wireless N? 5 gigahertz exists as A at 54 megabit. N is a retalk or a rework of how the framing and on-air mechanisms work, which is actually frequency independent, which has common deployments at 2.4 and 5.8 gigahertz, but it can in fact operate on any band you want if you can find a way to put a chip there. Did you have somebody over here? Did I miss one? Okay. Any other questions? Anybody interested in how to do this network? Anybody stupid enough to help us next year?
What type of stuff is broken?
What type of stuff is broken over the years? Oh,
What stuff hasn't broken?
officially, nothing is. The question was, what has broken over the years, followed by what hasn't broken over the years. The answer is everything breaks. I am absolutely certain I can snap any network I find in half in a matter of minutes. That's professional hazard of building networks for a living. What has broke? Okay. Pretty much the first 12 hours on site are a disaster because we're trying to figure out where the wiring is, pull all the wiring in, determine what the needs are that somebody showed up with at the last minute. Inevitably, somebody will ask you for, and this is actually one case, 150 patch cords, 15 foot long, and 4 terabytes of disk space at the last moment. The answer is no, we'll see what we can do. Broken. Occasionally people have showed up and said, hi, I know, I'm going to be helpful. I'm going to show up with a BitTorrent client with a copy of, say, all of Notacon's historical talks on it and provide a local mirror of that. Turns out BitTorrent is smart. BitTorrent is not that smart. It does not note that you are, in fact, on the same L2 and just direct you there. It actually does spread it across most of the internet, thus destroying the entire uplink in one move. This ran all overnight. I looked at it for a while, and then I went and unplugged the box with a note saying, please don't. If you'd like to do this, please host it on HTTP and put signs up. It's a lot easier. It makes everybody's life easier. We have So when we were back at hotel number 1 and we had the wireless uplink to the internet where it was bring your own wireless, we did in fact get that link the monitoring system determined that the link was being abusively used and then got cut off overnight, at which point we had to call the ISP we were working with and say, yeah, we're Notacon. We move bits. And they go, yep, reset it and blanked it out. So that has happened. Occasionally people show up and try and do pen testing on our network. That mostly just makes the router angry, because one of the mechanisms we use, in addition to doing bandwidth shaping, bandwidth policing, we also limit the number of sessions any given IP address can generate. That's not only to protect the infrastructure itself, but also to protect everybody else from runaway crazy. Session limits are great. They make it so that, yes, you can have 10 or 20 sessions open. That's fine. You may not have 20,000 sessions open. And they just fail and nothing moves on. Wires get ripped out. Hardware gets stepped on. People plug wrong voltage into devices. And switches at the worst possible moment will decide to have their power supply fuse, then pop, and black smoke will come out of the back. That's an indication that the switch has failed and you shouldn't try and repair it. Just mark it as bad, go back into your stack and try and figure out how to deal with it, because attempting to repair hardware in the field is not practical. Adjust, adapt, and overcome. Everybody is expendable.
Who is the wireless ISP?
I honestly don't remember. I wish I did. Excuse me?
I believe it was NAC at the time.
NACS?
NAC, Cleveland. They're renamed to NTNet. But N, and then the number 2, and then net.net.
So,
I use them.
I'm not from around here. I'm 4 hours away. They were extremely helpful and wonderfully fun to work with, and it was great.
The former owner was Greg. I never pronounced his name, but he was one of the lead guys on the expert project. Did anyone ever ask for POE?
Yes, and we laugh at them. Repeat the question. Has anybody asked for POE? Yes, and we laugh at them.
Ever carry those little vectors?
No.
We've got 2 extra wires. They can inject.
Yeah, there's a point. POE comes in many, many, many flavors. I tried to make sure that I'm not about to inject power onto a line that is in a flavor that the device at the other end doesn't like, by making sure I never do that. We have, in fact, used POE before to power some of our access points when we had a different deploy. We choose not to do POE to anybody else's gear. This is one of those things you want to keep in the same administrative boundary. Because otherwise things go pop and then all the magic smoke gets out. And once all the magic smoke gets out, again, mark it as bad, put it away, don't try and fix it. That's not a today thing. Go find more Ethernet cables to drag.
You mentioned when I ran into a call on Thursday that the network set up an extra 8 hours compared to what we're expecting. What went wrong?
So the question is, when I was charging through the hall on Thursday, I mentioned that the network setup took an extra 8 hours than expected. What went wrong this time? Answer, our contact points for the hotel changed a week before the event without us being informed. At which point, all of the work that we were expecting to be done for the uplink wasn't done, which meant that we had to do a last-minute scramble to figure out where we uplinked at, where we found our connection at, and how we interacted with the hotel's existing wired network. This takes time, phone calls, and an awful lot of talking, which we prefer to do months in advance. We didn't have that opportunity this time, so it was a matter of Thursday night running around calling people and asking, hey, can you help us? we're here for this event, and doing it on Monday isn't really an option. Because clearly we won't be here on Monday. Any other questions? I'm going to see no response from the audience. Take that as a no. And say thank you all for coming. I do apologize. I didn't have slides for this. I wasn't expecting to be giving it today. But sometimes we make it up as we go.